Experiments weighing up to 1,000 pounds and up to 3 feet in diameter are loaded into a 1,500-pound, 13-foot tall drop vehicle. The drop vehicle contains battery packs that provide power for the experiment, high-speed video cameras, and data acquisition and control systems. During the drop, test parameters are recorded such as pressure, temperature, and gas or liquid flow rates. Video cameras with recording speeds as high as 4,000 frames per second record images of the experiment. Once an experiment has been readied for testing, the drop vehicle's skins are attached to enclose the hardware. The crane operator picks up the release mechanism, or A-frame, and positions it over the drop vehicle. The A-frame and drop vehicle are hooked together, and the crane operator moves the pair to the top of the vacuum chamber. The drop vehicle is suspended at the top of the chamber by a hinged plate, held closed by a specially designed bolt, which will be fractured when the drop vehicle is released. The crane lifts, moves, and lowers a steel dome over the A-frame and drop vehicle, sealing the vacuum chamber. 2 keyed steel rods are inserted through the dome to allow the technicians to pull the safety pins once the air is removed from the chamber and the experiment is prepped. With 5 vacuum pumps located in the facility and the help of GRC's Central Process Services, air is pumped out to produce a vacuum. During the hour-long process, technicians monitor air pressure, which is reduced from normal atmospheric pressure, about 760 torr, to about 0.1 torr. Communicating through the connected cable, they can see live video to configure the experiments and execute pre-drop sequences. Pushing the fire button starts the drop sequence and the experiment timing. The large electrical connector is pulled from the top of the drop vehicle, and a hydraulic cylinder is activated that applies a load to the top of the hinged plate release mechanism. This load, combined with the weight of the drop vehicle, breaks the bolt holding the hinged plates closed. The drop vehicle free falls 432 feet. The experiment ends when it lands in a 20-foot deep container full of expanded polystyrene beads. It's traveling about 113 miles per hour when it hits the deceleration material and is stopped in 12 to 15 feet. Once the vacuum chamber has been vented back to standard atmospheric pressure, the crane operator takes off the dome and A-frame and lowers a cable to the decelerator to retrieve the drop vehicle. Technicians descend to the bottom of the shaft in an elevator and vacuum up the deceleration material around the drop vehicle. They attach the crane to the drop vehicle and lift it up through the vacuum chamber and back over to its stand on the shop floor. Next, the skins are removed and experiment data is downloaded to a hard drive and provided to the scientist or researcher to analyze exactly what happened during those 5.18 seconds of microgravity.